1,000 meters below the surface, the sunlight has surrendered entirely. This is a blackness so complete that the concepts of day and night lose all meaning. Yet the darkness is rarely empty. More than half of the creatures drifting in this deep sea produce their own light. Survival down here relies almost entirely on bioluminescence. This chart shows how the visible light spectrum descends from the surface. Red light is swallowed almost immediately by the ocean. Blue light travels furthest, stretching down into the abyss. Because red light naturally disappears within a few meters of the surface, life in the deep ocean tuned itself to the only light available. Over millions of years, eyes became instruments for seeing blue, and the ability to see red simply faded away. That physical reality imposes a strict law on the twilight zone. Everything that lives, hunts, and signals in the midwater does so in the same shared language of blue. Caught in the deep current, a tiny shrimp drifts passively. From its perspective, the surrounding water is completely empty. It has no idea it is already locked in a hunter's sights. The predator stalking it is a dragonfish. Barely the length of a pencil, its slender, featureless body drifts like a sliver of shadow against the vastness of the twilight zone. Beneath its eye, the dragonfish projects a beam of far red light directly onto the drifting shrimp. The prey does not flee because its eyes are physically incapable of registering the color. The dragonfish is casting a color that physically vanished hundreds of meters above it. More curiously, as a resident of the deep, it belongs to a lineage that should be as red-blind as the shrimp it hunts. By moving into the far red, the dragonfish stepped outside the shared language of the deep sea. It operates on a private visual channel that grants it total secrecy. If we pause the hunt at the millisecond the dragonfish switches its light on, we can examine the mechanics of this beam. The dragonfish does not generate red light from scratch. Its light organ initially produces the exact same blue bioluminescence as nearly every other creature in the mesopelagic. This conceptual model demonstrates the shift. The fish passes that ordinary blue light through a specialized fluorescent protein filter located inside its photophores. This barrier absorbs the blue energy and re-emits it as a deep crimson, shifting the light into a part of the spectrum that the rest of the deep sea is completely blind to. The dragonfish manufactures its own invisibility by recycling the exact same blue light that its neighbors waste on being seen. If we advance the timeline to the moment the dragonfish takes aim, the physical contradictions deepen. For this light to be a weapon, the dragonfish must be able to see it, an ability its neighbors lost eons ago. The biology of the dragonfish lacks the ability to produce the retinal pigment required to see red light on its own. To find that pigment, we have to look at what the dragonfish eats. It hunts tiny crustaceans called copepods, which have consumed specific bacteria capable of absorbing far red light. This microscopic schematic reveals what is happening inside the eye. The dragonfish extracts a chlorophyll derivative from its digested meals and physically installs it into its own retina to act as a booster for its vision. The fish's night vision is not grown from its own DNA. It is inherited and assembled piece by piece from the bodies of its prey. As the jaw begins to open, the physics of light presents another complication. In an environment where every flicker is noticed, a mouthful of enamel and bone would reflect the predator's own searchlight, signaling its presence. The dragonfish overcomes this by growing fangs that are perfectly clear. They vanish against the darkness because they barely interact with light at all. This tooth cross-section shows why. The outer layer is built from hydroxyapatite crystals, structured on the scale of billions of a meter. Because these crystals are smaller than visible light wavelengths, the light doesn't scatter. It simply passes through. That stealth is paired with a unique mechanical advantage. The loose jaw has no floor to its mouth, leaving only a bare frame of bone that moves through water with zero resistance. The combination of non-reflective glass fangs and a frictionless open-frame jaw creates a strike engineered for unblockable speed. Resuming the hunt in real time, the jaw rockets forward. It slices through the water and snaps shut before the prey can register a threat. The event is so rapid and so quiet that the shrimp is consumed without ever knowing it was being watched. In this single moment, the invisible beam, the stolen chlorophyll retina, and the nanostructured glass teeth all fired in unison. The strike succeeds because it is a masterpiece of stealth, executed in total secrecy from every other creature in the dark. We go to the deep sea expecting monsters with the largest jaws and most terrible size. Instead, we find the dragonfish, an animal that proves survival here relies on subtlety. This perfection wasn't designed, it was earned through millions of years of tiny accumulated advantages. A slightly clearer tooth or a slightly redder lamp meant the difference between starvation and survival. The mesopelagic zone is the largest habitat on the planet, and we have explored only the thinnest sliver of it. For every dragonfish whose secret we have read, there are surely others whose tricks we have not yet imagined. If you want to keep exploring the wildest frontiers of the planet with us, subscribe and join the channel. Tell us in the comments which deep-sea creature you would most like to meet next. The ocean keeps its inventions close, but we are only just beginning to see them.